Welcome to Math is Beautiful. In this video, we build the idea of the integral. Area accumulating under a curve, computed honestly with rectangles and a limit, and then used on a real flow problem. What does the integral of a function actually measure? We will earn the answer by computing one area that geometry cannot do honestly from scratch. Here is our function, f of x equals x squared, and the region under it. Here is the challenge. This region has one straight side, one straight bottom, and one curved roof. Ordinary geometry has no formula for a curved roof. We will have to invent one. The idea, what we cannot measure, we approximate with what we can. Slice the region into n thin strips and stand a rectangle in each. Rectangles we know how to measure. Why width 1 over n? Because n equal strips must share a total width of 1. And the kth strip begins k steps in, at x equals k over n. How tall is that rectangle? We let it reach up to the curve at its own position, height f of k over n. Since f squares its input, that is k squared over n squared. One rectangle's area, width times height like always. 1 over n times k squared over n squared, k squared over n cubed. Add every strip, k running from 1 to n. The total is the sum of the first n squares divided by n cubed. Keep this on the side. For that sum, there is a classic counting formula. Do not take it on faith, test it. For n equals 2, 1 plus 4 is 5. The formula, 2 times 3 times 5 over 6, 30 over 6, 5, it works. Substitute it into our park total and divide each bracket by an n. The rectangle area becomes 1/6 times 1 plus 1 over n times 2 plus 1 over n. Watch it converge. 10 strips, 0.385, 100, 0.338, 1,000, 0.334, the staircase is hugging the curve. Now let n grow without bound. Each 1 over n withers to nothing, and the total settles at 1/6 times 1 times 2, exactly 1/3. This result is important. And that limit has a name and a symbol. The integral written with this stretched s for sum, because that is all it is. The exact area under the curve, 1/3. Now let's look at an application of this concept. Water flows into a tank at a rate of r of t equals 2t liters per minute. The flow keeps speeding up. How much water accumulates in the first 6 minutes? Here is the rate, drawn against time. Why is the answer an area at all? Over any brief moment, the rate is nearly steady. Water gained equals rate times time, exactly a rectangle's area on this graph. Accumulation is area. So the total water in 6 minutes is the area under the rate line, from 0 to 6, the integral of 2t. But look at the region, no curved roof this time. The rate line is straight, so the region is a plane triangle, base 6, height 12. Half base times height, half of 6 times 12, 36. No limits needed when geometry already knows the shape. 36 liters flow in over the first 6 minutes. Integral computed, this time by triangle. So an integral is accumulation, rectangles under a curve, sharpened by a limit into exact area. Thank you for watching. If you found this video helpful, do like it, subscribe to Math is Beautiful, and share it with your friends.